everyone, this is Group 107, and we'll be presenting an Operations and Capacity Analysis of Diagnóstico de Laboratorio Argentina, also known as DLA. We'll be walking through the current state of their operations, identifying where things are going wrong, and proposing solutions to get them back on track. DLA is Argentina's largest independently owned reference laboratory, founded in 1976 by Dr. Fernando Mendoza. Today, the company operates 43 labs across Argentina, Chile, and Uruguay, with roughly 775 total employees. Their central lab in Buenos Aires processes 5,500 samples per day across 2 shifts. DLA serves 2 main markets: mutual health insurance clients who are sent to the lab by their doctors, and institutional clients like pharmaceutical companies, governmental agencies, and external labs. One important trend worth noting is that external sample volume has grown significantly, from 22% to 33% of total samples over just the past 5 years, which is a big driver of the capacity pressures that we'll get into shortly. So what exactly is going wrong? At the core, DLA's on-time 24-hour delivery performance is declining, and that's a serious issue for a lab whose entire value proposition is fast, reliable results. This is showing up in a few ways. First, labor costs are consistently over budget, driven almost entirely by excessive overtime as staff scramble to keep up with demand. Second, and most urgently, 2 of DLA's major customers have personally reached out to the CEO, threatening to take their business to a competitor if turnaround times don't improve. Beyond the demand side, there are also structural problems inside the lab itself. The central facility is spread across 5 floors and has only a single elevator, which creates real physical bottleneck every time samples need to move between departments. On top of that, samples frequently get misdirected to the wrong testing group, wasting time that the lab simply doesn't have. And while a move to a larger single-floor facility outside the city is being discussed as a long-term fix, that's still in early planning. DLA needs solutions now.
Here, we mapped DLA's current sample flow from intake through final storage. The process begins with 3 main sources: on-site samples, DLA satellite labs, and external labs, which account for about 37%, 30%, and 33% of total volume respectively. After intake, samples either go directly to distribution or move through separation first. Separation is important because about half of all samples go through this step, and each separated sample creates an average of 2.3 downstream outputs. That increases the workload flowing through the rest of the system. From there, samples move through distribution, testing, results communication, and storage. We also included the retesting loop because about 10% of daily samples re-enter the process, which adds hidden load and contributes to congestion. To identify where the process is breaking down, we compared the daily capacity of each major step using the staffing and time data from the case. Assuming 2 7.5-hour shifts per day, our analysis shows that separation has the lowest daily capacity at about 4,417 samples per day, making it most likely bottleneck. This matters because separation is not a minor step. Around 50% of samples go through it, and that step multiplies downstream workload by creating 2.3 outputs per sample. So even though other parts of the system may have more capacity, the overall process is still constrained by this weaker point, especially once retesting is added back into the system. Finally, the issue is not just average demand, it is also variability. DLA processes on average 5,488 samples per day, but the standard deviation is 1,418 samples. And the highest day in June reached 7,975 samples, which is about 45% above average. That means average demand can look manageable, while peak days expose the system's real capacity problem. This is made worse by unpredictable deliveries from satellite and external labs, along with the 10% of samples that return for testing. Overall, DLA is struggling not only because of limited capacity, but because that capacity does not match the variability of demand.
Now that we have seen where the process is breaking down, I will present the target goal and explain the key root causes behind these issues. The main goal is to restore the 24-hour turnaround time for the test results. To achieve this, the lab should aim for at least 95% of samples delivered on time. Another key goal is to increase capacity so the system can handle peak demand, which is around 80,000 samples per day. Currently, the system is designed for the average demand, which is much lower, and it creates problems on busy days. We also want to reduce overtime and improve efficiency, especially at the bottleneck. Now, I will explain the root cause of the problem. First, in terms of people, there are not enough staff at the key steps, which leads to overload during peak days. Second, the process itself creates major issues. The separation steps increase workload significantly because it multiplies the number of samples, and about 10% of samples require retesting and adding even more work. Third, the facility layout is inefficient. The lab is spread across 5 floors with only one elevator, which slows down the movement of samples. Fourth, the management plans staffing based on average demand instead of peak demand and does not account for variability. Finally, external factors like unpredictable deliveries and high demand variability make the situation worse. In summary, the system is failing because capacity does not match peak demand. The workload increases significantly due to separation and retesting, while staffing and the layout limit efficiency. The key issue is that the system is designed for average demand instead of peak demand, which leads to delay and overtime.
My capacity analysis shows that separation is the primary bottleneck. It can only support about 5,300 total samples per day, which is below DLA's average daily volume of 5,500, and far below peak days, which reach nearly 8,000. That means the lab is structurally overloaded, which explains the late deliveries and overtime. The best immediate solution is to increase separation capacity while also smoothing inbound deliveries and improving internal sample flow. DLA should add 2 full-time employees to the separation department. Separation is the main bottleneck, and current staffing provides only 32 labor hours per day, while peak day demand requires about 48 hours. This staffing increase would cost roughly $1,200 to $1,800 per month, depending on if employees are classified as lab technicians or not. But it would directly reduce overtime, backlog, and late results. However, instead of only adding labor, I also focused on reducing inefficiencies and variability, which can improve performance without increasing cost nearly as much. Another key improvement is optimizing how samples move through the lab. Right now, samples are transported across multiple floors using a single elevator, and carts are often only partially full, which creates unnecessary delays and wasted motion. By standardizing movement schedules, batching samples more efficiently, and improving routing between departments, DLA can significantly reduce transport time. This is important because even small delays at each step add up across thousands of samples per day. Improving flow doesn't require major investment, but it can meaningfully increase throughput and help relieve pressure on the bottleneck. DLA also faces highly variable daily demand, with some days handling nearly double the volume of others. These spikes can make it difficult to maintain consistent performance and often lead to overtime and delays. By introducing scheduled delivery windows for satellite and external labs, DLA can better control when samples arrive and spread the workload more evenly throughout the day. This would allow the lab to use its existing resources more efficiently, which in turn would reduce peak congestion and improve turnaround times without relying solely on adding more staff and increasing costs.
Now that we've identified the bottleneck and proposed a solution to increase capacity and align staffing with peak day demand, my role is to explain how we'll verify that this solution actually works and what risk we still need to manage going forward. The first part of our follow-up plan is focused on daily operational monitoring. We'll track 4 key indicators. First, on-time delivery rate, which is a core promise DLA is currently failing to meet within 24 hours. Second, weekly overtime hours, because overtime has become a major symptom of system instability. Third, sample misdirection incidents. These errors slow down processing and create unnecessary rework. We want to see those numbers fall and decline. And fourth, our customer complaints, which give us a real-time signal of whether service reliability is improving from the client's perspective. To make these improvements hold, we'll use a 30, 60, and 90-day review structure with Dr. Mendoza. At 30 days, we're looking for early stabilization and evidence that the bottleneck is easing. At 60 days, we want to confirm that performance remains strong during peak volume days, which can reach nearly 8,000 samples. And at 90 days, we evaluate long-term sustainability and identify any remaining constraints that could threaten the 24-hour turnaround that we are currently failing to meet. If the solution is working as intended, we should see a clear before and after shift. The bottleneck capacity should meet our expected peak day demand, turnaround times should consistently return to the 24-hour target, overtime should drop back to normal levels, and overflow across the 5 floors should be noticeably smoother with fewer delays caused by misrouting or retesting. However, there is still a risk we need to acknowledge. The big one is continued volume growth. Demand has been rising steadily, and even after increasing capacity, future peaks could exceed what we've designed for. Another risk is staff resistance to demand-based scheduling. If employees push back on the scheduled changes, the improvements may not fully take hold. We also face unpredictable delivery timing from external labs, which can create sudden surges that no internal process change can completely control. The growing complexity of test types, now over 1,500, adds variability and increases the likelihood of retesting. And finally, the physical layout remains a structural constraint. The single elevator and 5-floor setup limits how fast samples can move, regardless of staffing or processing improvements. So while our recommended solution addresses the immediate operational breakdown, the long-term path moving forward still includes relocating to a single-floor facility that is more easily manageable. Our follow-up plan ensures that the short-term fix is effective for now, while the organization continues preparing for the long-term transition. Thank you.